Welcome to IOQM 2023 paper. This is the part 4. So we are going to solve the 5 marks questions 21 to 24 in this video. For a given function n belongs to a natural number, consider non-negative integer valued functions f on 1 to n satisfying f of I is greater than or equal to f of j for I is greater than j. Okay. And sum of I equal to 1 to n of I plus function of I equal to 2023. Choose n such that sum of I equal to 1 to n function of I is the least. How many such functions exist in that case? Okay. So only thing I heard is the non-negative integer valued function f is not completely correct. They meant to say 0 and positive integers actually. So 0 also part of the function. Only then this whatever answer they have given is correct. Otherwise, it's not correct. Okay. So let's look at the solution. What is given is sum of I equal to 1 to n, I plus function of I equal to 2026. This means if I take sigma inside, sigma of I and sigma of function, right? As we know, sigma of I equal to 1 to n is nothing but sum of first n integers, which is n into n plus 1 by 2, right? So I just wrote it and simplify further. Basically, this sigma function should be the least function. So this should be least only if this should be maximum. So the maximum integer value possible is which is less than 2023 is at n equal to 63. Okay. So at n equal to 63, the value is 2060. Uh, 1 plus 2 plus 3 up to n. Okay. So if you subtract, what you will get is sum of I equal to 1 to 63, f of I equal to 7. Okay. So this is the function we have to derive. Okay. So this is the function we have to define now. How we can do is different ways we can define like this. Let's say I am taking only the last 7 f of i's. Okay, that is 57, 58, 59, 60, 61, 62, 63. Why? Rest all are zeros anyway. Rest all functions f of i's are zeros anyway. And this sum of 7 I can write in various ways. Okay, each f of I is 1, 1, 1. So 1 plus 1 plus 1 I'll get 7. Okay, this is one way I can write, correct? Or I can write the last function f of 63 as 2 and other 5 as 1, 1, 1, 1. Okay, so this way I keep checking how many different ways I can make. So this is the number of ways. These are the number of ways I can make actually. Okay, so 15 total completely 15 ways I can make actually like this. Okay, okay. So completely 15 ways is what I can make. So answer is 15 such functions exist. This is the answer. It's definitely hard. And of course, we have to understand that there is a small correction here. So I don't know what will be the Olympiad board, whether they will give marks to everybody or not. I'm not sure. Yeah, an equilateral triangle of side length 6, 6 pegs are placed at the vertical uh, vertices and also evenly along each side at a distance of 1 from each other. Okay, there is a equilateral triangle of length 6 and you placed some pegs at the distance of 1 each. That means you will place basically 5, right? Okay, and a 6 length you can keep 5. Okay, 4 distinct pegs are chosen from the 15 interior pegs. Okay, let's see the diagram, you will understand easily. Okay, this is each side is 6 length. So there are pegs placed at one distance. That means 5 on the each side you will keep basically. Okay, 5 on each side you will keep. Okay, now from this 15 interior pegs, okay, 4 distinct pegs are chosen Okay, and each peg is joined to the respective opposite vertex by a line. Okay, like this. I choose, let's say, A2 and A4. A2 opposite vertex is C, so I join to C. B4 and B2 I join to A because that is the opposite vertex. Okay. If n denotes the number of ways, we can choose the pegs such that drawn line segments divide the interior of the triangle into exactly 9 regions. I should choose these pegs in such a way that I should get 9 parts. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? So this is the question. Okay. Exactly. Find the sum of squares of digits of n. Okay. How many ways I can make? That is n. And then n sum of squares of digits I should find. Okay. So there are two cases possible where these lines can actually get 9 parts inside the triangle. Okay. This is the case one is shown. Two, basically two and two opposite sides. Okay. Cutting each other. Then you get 9 parts basically. Okay. So this is one way, case one, I would say. To get 9 regions, we need to draw 2 lines from one node and 2 lines from the other. Okay, this way I will get 9. So how many ways I can choose these two? Okay, I can choose first I can choose any 2 sides from the 3. Okay, either A side, B side or C side, any 2 sides I need. So that is 3C2 ways. Then each side 2 points can be chosen out of 5 in 5C2 ways. Correct? Out of 5 I need 2, so 5C2 ways. So total number of bases 3C2 into 3C2 into 3C2 into 5C2 into 5C2, which is 300. This is for the case 1. Okay. Now case 2. Case 2 is two diagonals can, three diagonals can actually cut each other. Okay, at the same point, or they become concurrent at one point, and then fourth line can be anything. Okay. So this is the other way. Okay, so in this case, I should find out how many ways 3 lines can be concurrent. Okay, 3 lines can be concurrent from Seva's theorem. Basically, what it says is you need to have same ratios, right? Possible ratios is m by n by n, and 1. Okay, so that means I can choose C1. If I choose, I should choose A5. Okay, these 2 lines, and this is a midline anyway. Okay, if I choose B and C2, then C and A4. It should be same ratios. It should be. Then I will get uh, concurrent with the middle line. Okay. So let's see how many ways this can be done. First thing, this midline A B3 can be chosen 3 ways. Either I can draw from here or CA3 or B C3. Correct. So that is done. Next, other 2 lines can be drawn in any of the 5 ways. Correct? 4 ways, sorry. 1, 2, 3, 4. Okay? Without the midpoint. Okay? 4 ways I can draw. That is 3 into 4 plus 1. Okay? Okay? Okay, plus 1 is for all lines joining the opposite midpoints. Okay, that's for the plus 1. Otherwise, it is 3 into 4. Okay, next. Fourth line can be drawn any remaining. That is, there are 15 points. 3 are already chosen. So 12C1. 12 ways I can choose the last line. That is 12. Okay. So this way I will get total number of ways as 13 into 12. Okay. So 3 ways. 3 ways I can choose this line. 4 ways I can choose this without mid. Okay. Because midpoint is only one way. I cannot have 3 ways, right? So 3 into 4 plus 1. 1 is for all joining at the midpoint, like C3 to B, A3 to C, and A to B3. This is only one way. So that is 13 ways. And then 12 ways I can choose the last line. So 13 into 12, which is 156. So total weighs from both cases 300 plus 156, that is 456. This is n. So the answer should be 4 square plus 5 square plus 6 square, which is 77. This is the answer. It's also hard. Next, in the coordinate plane, a point is called lattice point if both of its coordinates are integers. If A be the point 12, 84, okay, find the number of right angle triangles ABC in the coordinate plane where B and C are lattice points having a right angle at vertex A, okay, and whose incenter is at the origin. Okay. So incenter is at the origin and one of the vertices, that is A, where right angle is formed, is 12, 84. So just to simplify the problem, let's simply shift A to origin. Okay. So once I shift A to origin, what happens to I, which is actually it is 12, 84, it will become minus 12, 84. Okay. Previously, previously the triangle is above x-axis, right? A is above x-axis. I is at 0, 0. So I'm shifting it so that I is at minus 12, minus 84. A is at 0, 0. Okay. Now solving this is very easy. Okay. We need to find number of triangles with vertices B, C, also lattice points. Okay. Lattice points means they should be integers basically. Okay. Slope of AI, okay, is 45 degrees because AI is the incenter, I is the incenter, right? So AI is the angular bisector of this 90 degrees here. So that is 45 degrees. Okay, it's the angular bisector basically. So which is y2 minus y1 by x2 minus x1. If you take slope is 84 by 12, which is 7. Okay. Now AIC equal to 45 degrees. I said just now, I told you it is angular bisector, so it will be 45 degrees. Okay. Now let M be the slope of AC. M be the slope of AC. Okay. So now tan 45, that is this 45 equal to, okay, M slope, that is M, okay, minus tan of minus slope of AI, that is 7, by 1 plus 7m. Okay, you apply the tan rule basically. Slope is nothing but tan theta, right? So this is full angle, okay, and I need 45 degrees tan 45 value. So this is full angle, that is m minus n by 1 plus 7m. Okay, tan A plus B formula I am applying. Okay, that is equal to 1 because tan 45 is 1, we know already. So 1 plus 7m equal to m minus 7, which means m equal to minus 4 by 3. That is slope of AC is minus 4 by 3. Since AB is at 90 degrees to AC, slope of AB will be 3 by 4. Okay, negative reciprocal. Okay, now we can say that B is minus 4t comma minus 3t. Okay, and C is 3k comma minus 4k. Okay, so with these values, we can actually find out what are the lattice points of B and C possible. Okay, okay. So how we can do that? A equal to 0, 0, B is this one, C is this one, right? Okay. Now AB equal to phi t, AB equal to phi t, correct? That is, you just apply square root of y2 minus y1 whole square plus x2 minus x1 whole square, you get phi t. AC equal to phi k. Again, same thing, same rule you will apply. BC equal to phi times square root of t square plus k square. Okay. Now these three are, we know that with the in radius they have a relation, correct? So in radius equal to R equal to AI cos 45, which is equal to 60. Okay. AI is AI cos 45, which is 60, or in radius. Okay. Now equations for sides and in radius is BC equal to AB plus AC minus 2R. This is the equation. Now you apply this one. Okay. If you apply this one, 5 into t square, 5 square root of t square plus k square equal to 5t plus 5k minus 120, or square root of t square plus k square equal to t plus k minus 24. Okay. Now, squaring on the both sides, what you will get is t square plus k square equal to t square plus k square plus 2tk plus 576 minus 48 into t plus k. Okay, which is implies this value. You simplify further, basically what you will get is t minus 24 into k minus 24 equal to 288. Okay, so 288 I can write it in the prime factor method as 2 power 5 into 3 square. Okay, so how many possible primes are possible here? Since both are integers, okay, t and k should be lattice points, right? They should be positive values. For that one, each one should be equal to one of the factors, right? So how many are possible? 6 into 3, that is 18 possible factors, divisors of 288 are possible. So that is 5 plus 1 into 2 plus 1. This is the trick actually. Okay. So, right, t minus 24 can be any of those divisors to satisfy the lattice point rule. Okay. So, basically you have 18 such possibilities are available. Okay. So 18 is the answer. This is also hard. So, as we go into the 5 marks questions, all are hard actually. Let's see next. Okay, trapezium in plane is a quadrilateral in which a pair of opposite sides are parallel. We know this. Trapezium is said to be non-degenerative if it has a positive area. Find the number of mutually non-congruent, non-degenerative trapeziums whose sides are four distinct integers from the set 5, 6, 7, 8, 9, 10. Okay. So there are basically two kinds of trapeziums possible. One is inside, one cuts the uh, cuts the rectangle, one extends the rectangle. Okay. So if you take the four sides as A, B, C, D, A, B, C, D. Okay. This is if you call this part as X, then this will become C minus A plus X. Okay. So similarly, if you call this one X, it will become A minus C plus X. Now with this we can solve this problem information. So we know that A is greater. We will assume basically A is greater than C and D is greater than B. Okay. Now this is one assumption, one rule basically for the sides. From first trapezium, D here, uh, if you say this side, this is right angle triangle, right? Side of the right angle triangle, so D square minus X square, which is equal to in this triangle, okay, same, right? This is nothing but B square minus C minus A plus X whole square. Okay, right? Now from the second triangle, so second trapezium. Here it is same, d square minus x square equal to b square minus a minus c plus x whole square. Okay. If you clearly observe, both equations are actually same. Okay. You can write c minus x plus c minus a plus x uh, a whole square as a minus c plus x whole square. Right. Both are same actually. Okay. So you take one of them, d square minus x square equal to b square minus a minus c whole square minus x square minus 2 into a minus c into x. Okay, expanding. So, which means x equal to what the value I will get is d square minus b square plus a minus c whole square by 2 into a minus c. Okay. So, x is basically less than d. Okay, since x is between 0 and d. Okay. So, if you apply this, a minus c whole square plus d square minus b square minus 2d into a minus c is less than or equal to 0. You simplify this further. Okay, this is what you will get. A minus c minus d minus b into a minus c minus d plus b is less than 0. Okay. Okay. Simply, if you summarize this, it is nothing but a plus b is greater than c plus d, or A is greater than C and D is greater than B, because we have already this one, right? So this is one equation, this is other equation. From these two inequalities, basically, uh, we should derive the values for possible values for the trapezium. Okay, so this is one and this one. Okay, case one. If A is 6, A cannot be. Can A be 5? Is it possible? If A is 6, okay, since A is greater than C, C has to be 5. Now D is greater than B, so D equal to 10, B equal to 9. But A plus B cannot be greater than C plus D. Right? This is not satisfied. This equation is not satisfied. So A can be minimum value of A should be 7. For A equal to 7, two possibilities are there. 7, 8, 5, 9 and 7, 9, 5, 10. Okay, these are the two cases possible. So similarly, go ahead and try to find each case. For A equal to 8, how many total number of cases possible are 4. Um, you can just take the numbers and try them basically. You will find which should satisfy these two inequalities. That's it. Okay. For A equal to 9, we have total number of cases 9. For A equal to 10, total number of cases 16. So if we combine, total number of cases is 31. This is the answer. Yeah. So this is also definitely hard. So it's getting really tough in this IOQM in the especially the 5 marks questions, right? Okay. Let's see the other questions in the next upcoming video. Thank you.